Good afternoon, everybody. Coach K here with the Math Help channel. Today I'm going to be going over Mod 1, Lesson 5, using bar diagrams and double number lines to look at ratios and come up with equivalent ratios. So today we're going to start by using the bar diagrams to solve these ratio problems. Our question here: a survey of Mrs. Thompson's class shows that out of 30 students, 17 of them have a dog. How many of the 300 students in the school could be expected to have a dog? So obviously it's going to be more than 17, because that's out of 30 there were 17. So we're looking to make that and take a much bigger equivalent ratio and determine how much out of 300. We can use a bar diagram to do this. So I'm going to draw one big bar. And this is going to represent my 300 students. Now, I want to make groups of 30, and I can do this by creating 30 different boxes. So let's go 30 boxes. 1, 30 boxes. Woohoo. So, out of these 30 boxes, I say, okay, that 300, how much would go into each group? Well, I think if I have 30 groups, how much goes into each one out of 300? 10. 10 goes into each one. So each one of these little boxes represents 10 students. So now, I know that the ratio was 17 out of the 30. So what I want to do is I want to shade 17 of these 30 boxes. So I'm going to do that with the red marker. So 1 box shaded, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so I look at this and I say, okay, if each box represents 10 students, if I count these up, these boxes that represent the 17 out of 30, that will tell me how many students are expected in the school to have a dog. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170. So I can make the estimate and I can say out of 300 students, there should be 170 students that have a dog. I can back this up with the math that we have done in class, and I can say, okay, 17 have a dog out of 30 students. If I want to take that out of 300 students, I can see, how do I go from 30 to 300? I multiply by 10. When I do the bottom, I must do to the top. So I'll do 17 times 10. 17 times 10 is 170. So our diagram showed the same thing as our equivalent ratios, or as this proportion did. So we're looking at the same thing, we're just modeling it and creating a nice visual model to help us understand that. So that is how we use a bar diagram to solve this ratio problem. Let's try another one. So let's look at extra example 2. So this question, when it loads, gotta love technology, right? It's just so fast. So the last one we were looking out of a hole. This time we're going to take part and try to figure out another part. So, there we go. Eliza's mom teaches at a preschool. There is one teacher for every 6 students, so part to part. There are 13 total teachers. How many have to be students then? Okay, so I got to think about this. I'm going to create another bar graph here. I'm going to create another bar graph here. I'm going to create a bar with 6 setups. 2, 3, 4, 5, and so 1, 2, 3, 4, 5, 6. Perfect. Don't look even at all, but that's okay. So there is one teacher for every six students. So here are my 6 students. Here's 1 teacher. 1 teacher. So if I need to know, okay, there are going to be 13 teachers. How many students would that make? Well, if I know there's going to be 6 students for each 1 teacher, I just put a 13 in each one of these. Put a 13 in each one of these, and then I add them up, and I'll have exactly how many students I need to be in there. So 13 plus 13 plus 13 plus 13 plus 13 plus 13, or I can just go 13 times 6, because I'm a smart math student, and I know I'm taking 13 6 times. 18, carry 1, 6, 7. So I know there has to be, for 13 teachers, there are 78 students. Once again, I can model that with a proportion by saying 1 teacher to 6 students. I can model that with another proportion and say, okay, if I know there are 13 teachers, how many students will I have? Go from 1 to 13 by multiplying by 13. What I do at the top, I also must do at the bottom. Do 6 times 13 and get 78 students. So, once again, we're modeling that with a proportion. We just created a bar diagram to show how that proportion actually works. So, those are how we use bar diagrams. Now, we have one more strategy that we can use. We can use a double number line. Now, if I use a double number line, this works for some people, it doesn't work for others. It's up to you on which one you prefer to use. Double number line is just as it sounds. I'm going to create 2 different number lines based on the ratio that I am given. So in this problem, let's go. Makes for a great video when I'm waiting for technology to work, doesn't it? There we go. So 5 out of 12 students at Perry Middle School share a locker with another student. There are 456 students that attend Perry Middle School. How many students are expected to share a locker? All right, so if I want to do this, I need to create a double number line. All right, so my first number line, I know it's 5 out of 12, so I'm going to create a number line 5 out of 12. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'm going to make that 12, just so I know. So I can see 5 out of my 12. There's my number line. Now, I know 0 would be 0, because that just makes sense. 0 to 0. Now, if I had 12 students, there are 456 students. So that means at this 12, I'm also going to have a 456. Those 2 are going to be the equivalent parts. So I'm going to create a number line based on this, where I have everything lined up. So what I need to do here is I need to figure out, at this 1, how much goes into each equal part? Well, if I know there are 12 lines here, at the 12th line I have 456. What I need to do here is I need to take 456 and divide them into 12 equal parts to see how much needs to go on each line. So if I do that, 456 divided by 12, we'll do that one down here real quick. 12 can't go into 4, 12 can go into 45, 3 times, 4, 36, gets, borrow, that becomes a 3, that becomes 15, that gives me 9 left over, drop the 6, goes into 96, 8 times, yep, for 96, and we 0 out. So I know each group is going to be 38. So my first number, one locker, which if there was 1 student sharing, would be 38 students total for 1 locker. So I'm going to take this and I'm just going to keep adding 30 to 38 each time. 38, 38, 38, 38 to get to my 5. So that way I know if 5 students shared a locker out of 12, how many students would share a locker out of 456. So I'm going to do that. I'm going to say, okay, 38 plus 38, that's 40 plus 40 minus 4, so that comes down to be 76 plus another 38, so 76 plus 38, if I add them up, 14, carry the 1, 10, 11, so 114. So if I now do 114 plus 38, I get 12, carry the 1, 4, 5, 152. Oh, I only need one more 38 to get to my 5. So let's do one more 38. So 152 plus 38 gets me 10, carry the 1, 9, so 190. So I know from this that at 5 out of the 12 students, Sarah, that means 190 out of the 456 total will have shared the locker. And there we go. This is a nice one because it's a little easier for us to tell how to go from one to the other. So I know there are expected to be 190 students that are sharing a locker out of 456. I hope this has helped clear some things up. Once again, if you have any questions, always contact myself or Mr. Rinkus. Make sure to hit the bell at the top to get ringed for any notifications. Like and follow us as well. Thank you very much for tuning in.